Hi everyone, this is your 1.8 notes on scatter plots. A scatter plot is a graph that shows the relationship between two quantitative variables. The horizontal axis is used to represent one variable, and the vertical axis is used to represent the other variable. The data points are plotted as ordered pairs. These ones are not connected as they are in a line graph. For example, the following scatter plot shows the relationship between horsepower and highway mileage, so kind of like the power behind a car. For a selection of vehicles, it appears that vehicles with more horsepower get lower mileage on the highway, or they get lower miles per gallon. Notice that neither axis is at zero, starts at zero. This is indicated by a jagged start to each axis, which shows a break in the scale. So this shows that we skip values. So if you ever want to skip values, so like they went by fives here, so they did not have 5, 10, 15, 20. They just started at 25. So it allows you to make better use of your entire graph. When two variables are paired, the one that is thought to depend on the other one is called the dependent variable. The other is called the independent variable. This distinction is often a matter of perspective. For example, suppose you are driving 60 miles per hour. If you travel for 1 hour, then you will go 60 miles. If you travel for 2 hours, then you will go 120 miles. In this sense, your distance depends on the time. You might consider distance to be the dependent variable. However, you could also say that in order to go 60 miles, you need to drive for 1 hour. This is the perspective. Travel time should be considered the dependent variable. In a scatter plot, the independent variable is plotted along the horizontal axis. So this will be your independent. And then this one will be your dependent. And I like to think of this as a cause and effect relationship. So the independent is the cause and the dependent is the effect. That's how I like to think of these. Example 1. Given each scenario, identify the independent and dependent variables. Please remember when you do these that it is not going to be based on numbers. When we talk about the variable, we're talking about what the numbers represent, not the actual specific numbers. So for A, it says a tree grows approximately 6 inches per year and is 10 feet tall when planted. So we're looking at how much it's growing per year and the amount of time that has passed. So they give us the amount of growth and they give us the time. So our independent variable is going to be time. And it's going to be the time since planted. And our dependent variable is the height. And this one they give us, it's either in feet or inches. So the time, if you think of it like this, the time determined or affected what the height was. This determined that. Part B says, when a swimmer gets 8 hours of sleep the previous night, she is able to complete a 200-meter swim in 3 minutes. When she gets only 6 hours of sleep, it takes her 3 minutes and 16 seconds to complete the swim. So we've got her sleep affecting her swim time. So we're going to have her amount of sleep that will affect her swim time. So here are some steps that you'll use. After choosing which variable is independent and which is dependent, a scale needs to be determined for each axis. To determine the scale, consider the smallest and largest numbers that you would need to graph for each variable, and then choose a consistent increment or step. So the increment or step is the change in amount for the tick marks. And I'll explain this a little bit more. Once your axes and scales are determined, you'll plot each pair of values as an ordered pair on the graph. The value of the independent variable is the first number in the ordered pair, and the value of the dependent variable is the second number in the ordered pair. So, and then I have a few other extra steps to help you along the way, but we're going to go ahead and just start with our first example. As just a tip, almost always when they give you a table, the first variable is going to be your independent variable, and the dependent variable will almost always be the second one. So example 2 says, consider the following data on years of experience and salaries for the employees of a small business. Create a scatter plot of the data. So our independent variable is the amount of experience that they've had in years, because that will determine what the salary is. Salary doesn't determine experience. Experience is kind of like what we can think of as our baseline. That's what we will use to determine what someone's salary is. Okay, I'm going to have us look at what each of the variables are. So we've got experience, and then we have salary. And if it's on the x-axis, that one is our independent. If it's on the y-axis, that one is our dependent. So when we make our graph, we now already know what is going to be our independent and what is going to be our dependent variable. We've got our independent, which is going to go along this axis. So this one is going to be your horizontal axis. This one is going to be your vertical axis. So we're going to put experience in years here. And then we're going to put our salary over here. Now, our experience in years ranges from 0 all the way to 23. So when I think of values that I want to use for my tick marks, for this I would start at 0. And I could go by something like 4s or 5s. Any of those would be appropriate. I'm going to just go by 4s. And we want to go to at least 23 or higher. Okay, so now I have all the tick marks for what I have for the independent variable. So using those, what I wrote, I'm going to put what the min, max, and increments were. These are the values not for the data, but for the graph. So think of these as the values that you're using on your graph, not just what's listed here. Because the max is technically 23 here, but we went all the way to 24. So we went 0 to 24, and we went by 4s. All right, so for our dependent, the lowest number is 48,000 and the highest is 92,000. I like to go by numbers that make a little bit like cleaner, easier ways to actually like go by increments. So I'm going to start at 40,000 because remember, you don't need to start at 0. So I'm going to make that jagged start and I'm going to start at 40,000. Now you could go by like 5,000s or you could go by, I wouldn't necessarily go by 20,000s. That's probably not enough. So I'm going to go by 10,000s. And again, you want to make sure that you go at least to that value that you have or higher. Okay. I'm going to go ahead and also add a title. So for the title of this, I'm going to name it Salary versus Experience. As long as it has to do with the graph, that's fine. Okay, I'm going to pause the video so that I'm going to, and then I forgot to include this. So our lowest value along the y-axis or the vertical axis was 40,000. And our highest was 100,000. And we went by 10,000s. All right, I'm going to go ahead and plot the points. And to do that, I'm just going to pause the video so it doesn't just take up a bunch of time. Okay, so I plotted all of our dots. I apologize that it went a little bit into the table and everything else, but that gives you a good idea of how to do a scatter plot. Mathematicians often look at scatter plots to try to find a general pattern that the data points seem to follow, even if it is not a perfect fit. This process of choosing an appropriate graph shape to represent the trend in the scatter plot is one type of mathematical modeling. For each of the following scatter plots, you'll sketch a smooth curve to follow through the points that indicate the model that you think the data points seem to follow. The line or curve should look like it passes through the center of the cloud of points. It does not need to necessarily go through each point or technically even any point. When I do these, I like to think of it as we want about half the points above and half the points below the line that we draw. So for instance, this one right here, if I draw a line about, oops, that's a little bit too thick, give me one sec. To draw a line right about here, about half our points are above and half our points are below. Same idea, oops, let me go a little bit higher with that one. Like that, about half our points are above, half our points are below. Now this one curved a little bit, so we can see it going up and then it going down. So we're just going to show that U shape with that. All right, these are actually called different shapes. This one would be a linear because it's showing just a straight line. This one is going to be a linear decreasing because we read our graphs from left to right. So if it is going down from left to right, it is decreasing. Whereas this one would be a linear increasing. And this one, it doesn't really have a fancy name. It is just called U-shaped. The only other type of graph that you guys would run into during the notes would be something that is called exponential. So if it has a general shape of slowly starting to go up and then quickly increasing, this is going to be called exponential. For example 4, we're going to match each description to the graph that you think best illustrates it. Identify the independent and dependent variable in each case. So in example 4, we're going to match each description to the graph that you think best illustrates it. We will identify the independent and dependent variable in each case. So I'm actually going to have us start with the middle here. So for D, it says the height of a ball each second after it's shot from a catapult. So when we think about this, it's probably the most visual out of all of them. And so that one would be this one right here. So this would be D. So as we think of this, the independent variable is our time, and the dependent variable would be our height of the ball. Okay, the other one that I'm going to have us do is B, the average monthly temperature in a given location. So when we think of spring and then going to summer and then fall and then winter, the temperature is going to go up, and then it's eventually going to go down, and then it's going to go back up again. So that would be this one right here, the fifth one. So that is B. So we can say that it's month and then the temperature. Okay, the next one that we'll look at is A. It says you save the same amount of money each month in a non-interest bearing account until you reach your goal. Then you leave the account at that balance. So it's going to increase at the same rate. So that's going to be linear. And then we're going to see it just stay the same. So that would be this last one right here. So we're going to have time, and then we're going to have the amount of money be our dependent variable. Okay, let's go ahead and look at C. It says the population of bacteria doubles every hour. So we're going to see it just quickly increase. So that would be this one. So we have our time, and then we have our population of bacteria. E is the number of days needed to build a bridge compared to the number of workers. So if we think about the number of workers that we have, if we have, that's going to be what determines the amount of time it will take. So that would be our independent. And if we think about if we have a few workers, it's probably going to take a long time. But if we have a lot of workers, it's probably going to decrease the amount of time that it takes to build a bridge. So that would give us this one right here for E. So we're going to have the number of workers, and then we're going to have the number of days that it takes to build it. So that gives us this last one as F, which is the number of students on a college campus who contract a highly contagious flu virus. So we have the amount of time, and then we have the number of students, which this does look very similar to things that we saw with COVID and such. Okay, for example 5, I am just going to pause the video and I'm going to fill this in, and you can check and look and see what I have for my answers, and you can compare it to your own, or you can even just copy down what I eventually have. Okay, so here are the information that I used for the graph. We have our high school GPA, which was our independent variable. So that was on the horizontal or x-axis. Our college GPA was our vertical or our dependent variable, which was on the vertical or y-axis. I went by 0.5 for both. Remember that you do not need to go by the same amount each time. So like in the last problem, we looked at salary and experience. They didn't go by the same increment, so it just depends. And that is our graph. And then the conclusion that we can draw is that the lower the high school GPA, usually the lower the college GPA. So we can also say as the high school GPA increases, the college GPA increases. Okay, this ends your section 1.8 notes. If you have any questions, please feel free to reach out.